Morning. I'm Davide.
I'm Michelle.
This is Hyperscaler's operating system strategy working with Fedora and CentOS. We are gonna go over a quick introduction, give you a very quick primer on the infrared meta to set the stage. We'll talk about how we use CentOS, the work we're doing upstream, and then we'll have some closing words. Sorry, people were making gestures from the outside. All right. We both wear many hats and do many things. This is technically a meta talk, so we are wearing, at least I'm wearing corporate attire.
Sorry, I didn't get the memo.
But yeah, we are both very active in open source in various spaces, and we try to do work in the community whenever we can. And we both enjoy doing this kind of work. We are at Meta on the Linux user space team, which is kind of like the kernel team, but for Linux user space. Oh, do you have a microphone for him? Thank you very much. Thank you. Then we can, this is much less awkward. Yeah, I think you're live. Okay, excellent. Our team deals with bridging the gap between the open source community and the internal deployment, especially around the system space. This is kind of like a kernel team, but for things that are not the kernel. So we do a lot of work around CentOS and Fedora and systemd and generally low-level systems user space. We also do a fair bit of open source software development on our side, and we'll talk a little bit about that later on. Do you want to talk about?
So yeah, you might be wondering why do we work upstream, especially hey, we are in a big company. Why are you working upstream? And basically, no matter how big you are, basically most of your building blocks will be open source these days, and it's kind of basically it's win-win to actually contribute instead of just forking everything and trying to maintain everything yourselves. And yeah, big companies, big tech, it's famous that things move quite fast, but still we don't have the ability to keep up with everything that's happening upstream. So there's no point trying to just fork the world. We have had mishaps in the past where which some of them we will talk about, where oh, why don't we just do this ourselves? And it's not pretty. And yes. If you share the code, that means you share the maintenance burden as well, and it's not that you might discover that 5 other companies are doing exactly the same thing, and they all spend so much time rebuilding the wheel.
Yeah, it ends up being relatively easy to make a business case for doing this kind of work, even in a standard corporate environment. At the same page, one thing that we found fairly early on is that there are different ways one can approach this, and by far the best way to approach it is to just participate in the communities as a member of the communities. With the environments where we had the most success have been environments where engineers would just start being involved in projects, show up at meetings, try to solve problems, try to, in general, be useful. And then later on, you get a chance to talk to people and to maybe try to influence things in a direction that is mutually beneficial. Or you can try to get assistance, getting a feature you needed merged, or work together on developing things, or maybe later on become co-maintainers of a project or become more involved in leadership. But there's no shortcut here. You have to actually put in the work. You have to show up in these spaces. You have to foster this relationship, and it just takes time, and it takes effort, and it takes people that are willing to do the work there. Let's go over quickly on infra. Otherwise, this talk will not make a ton of sense. We have a lot of machines. We have millions of physical machines. We have tens of millions of containers. These are spread across the globe in data centers. These are all a wide variety of SKUs. These are not homogeneous systems. We have dozens of different SKUs. These machines all run Linux. They all run CentOS. They all run roughly the same open source stack, which is CentOS Stream these days. They run Linux. They run systemd. We use extensively systemd, and we use Chef for config management. The hardware of this machine is, in the vast majority of cases, custom hardware that comes as part of Open Compute, and it's custom in the sense that it's been custom designed, and then the designs are contributed to the Open Compute Foundation. And then we have various companies generally in Far East Asia, that will build them out and sell them to us or lease them or whatever makes sense. And then we get them deployed. But these are open source design, and everybody else can do the same if they so desire, although they are somewhat quirky designs, I would say. So they might not make a ton of sense in a standard data centers. They are available. These include servers, but it also includes network switches, backbone networking infrastructure, and kind of everything you see in a data center down to the data center itself. What's up?
I just need a picture of my
Please. Oh, okay. Is that better?
Yeah.
Thank you. No worries. The way the infra is set up is generally that there are a team responsible for the health of the physical machines themselves, and then for the health of kind of the software stack and the platform on them. But then it's up to individual teams to manage their own application or their own workload on these machines. And most things these days run onto containers, so a lot of teams will interface primarily with just the container platforms, but there's still stuff that runs on bare metal, and in that case, folks will end up interfacing with the OS and with the platform that's provided there. And as I mentioned, the stack is Linux, CentOS, systemd, and Chef. Going over these quickly, we run obviously the Linux kernel. We do not run distro kernels. We run kernels that are built off Linux and tend to track Linux fairly closely. Generally, what this looks like is that is some version branched off Linux, and then various backports are applied depending on what's needed, with the general rule that we don't backport things that don't have a future upstream. So people will do development upstream, and then they'll get their features submitted, and then they might backport them internally to be able to deploy them and test them, and then be able to go back upstream and say, hey, we ran this thing on, I don't know, 200K machines, and it didn't blow up. Hopefully that's useful signal, and that informs the review process upstream. But we won't have downstream only things that have no path to upstreaming. This is also true for vendor things. Vendors love to give you a kernel tree with random garbage in it. This is not ideal, and it is not conducive to maintainable solutions. So generally speaking, the approach there is that whatever we end up deploying has to have some sort of path upstreaming. And that can be the vendor doing the upstreaming, or us doing it, or working together, or some combination thereof. But we do not want to have downstream only stuff. It is madness otherwise.
We probably should mention we compile our kernel with Clang and not GCC.
We do compile the kernel with Clang. We have a lot of work actually put into Clang. We use Clang with PG optimizations fairly extensively. We ended up doing a fair bit of work on the kernel live patching infrastructure to actually support this better. These all went upstream. We use KLP extensively to deploy fixes and not so minor things. It's also used quite a bit to do troubleshooting in the field. So we could use KLP, for example, to inject some debugging functionality that wasn't there, or in stupid case, it could be just a print key or something. And then that can help debug a problem in the field without having to reboot the system and just having a live machine. We have a lot of upstream kernel maintainers employed at the company that do all of their work upstream. So we have folks that work on Sirius, on BPF, on Btrfs, on IO-Uring, on memory management, on all kinds of things. But these are all developed. These are all developed on the mailing list in the open.
Debugging is probably easier nowadays with BPF trace, right?
Yes, we also we should have had a slide on that. We also do a fair bit of work on kernel adjacent debugging tooling. So things that, as you said, things like BPF trace, things like Dragon, all these sort of tools that tend to make life easier, that are open source projects of their own, that are available, that people can use, that originated generally from an engineer having an itch to scratch and wanted to do something with it. Then we have CentOS, which is the operating system that we run on the fleet. I joined the company in 2012. In 2012, we were running CentOS 5, CentOS Linux 5 everywhere. I am told before then, at one point, some version of Fedora Core was running somewhere, but I never found proof of that. We ran 5 for quite a while. At one point, somebody decided maybe we should try to move to 6. That was a fairly haphazard process because nobody was really tasked with doing it. And it was it took several years to get through that. 6 to 7 was slightly more organized. 7 was also when systemd was introduced, which was very interesting because back then we were running obviously sys5 or Upstart, but Upstart in sys5 emulation mode because that what distribution was shipping. And if you ever ran a sys5 system, sys5 is not a conductive supervisor thing, so people would write all kinds of tiny system service supervisors. I think at one point we had like a half a dozen ones, including one written in PHP, to just like demonize things and keep them alive and send them signal. We had a lovely thing where you had a web dashboard where you could put in a string and the string would be like passed down and parsed into a signal, and it would send the signal to all of the processes that the supervisor was monitoring. I do not recommend designing your systems that way. These all got replaced with systemd, but obviously that was a big change that took a fair amount of work. It involved deprecating a lot of existing systems and sunsetting them. We then did 7 to 8, which was also a fairly streamlined process. That was also when Upstream switched from CentOS Linux being a rebuild of RHEL to Stream being in front, well, depending on your reference, on the other side of RHEL, being used as the funnel that then RHEL is built from, which gave us a better chance to get changes upstream in CentOS Stream, because then you could contribute directly to the distribution itself. And then 8 to 9, and this year we started doing 9 to 10 in full force. Right now the bulk of the fleet is still running 9. We have some like 100 or 200K containers on 10. Containers are doing fairly well on 10. Bare metal, we're getting there. Most of the stuff is in place, but the mass migration is going a bit slow right now. But I'm hoping to get the container platform, which is the bulk of the physical fleet these days, started over quickly very soon.
Yeah, I think I joined when the 6 to 7 migration took place, and there are horror stories that we can relate later when we talk about
yes, 6 to 7 was very fun. Also, by the way, this is just production. We have non-production environment, like meaning IT or like where payroll runs, and that's all kind of fun. Like that's a mix of RHEL, CentOS, OEL. Does ITF Fedora? I don't remember.
I hope not.
I hope not.
No.
We do have Fedora on laptops. We'll talk about that later. And then systemd. We also run systemd, as I said. We run the latest systemd upstream. Systemd is kind of like the kernel in this context, that we have people that do a lot of work on systemd upstream. We have folks that are involved in systemd as maintainers. We've done a lot of feature development in systemd and a lot of co-design work with the systemd developers. Things that we worked on somewhat recently was the user space out of memory management daemon. There was a lot of improvement work on the journal. More recently, there's a lot of work on adding varlink APIs because everybody loves dbus, and it's nice to have an alternative to dbus in varlink that does not take your machine down if the daemon dies. Also work on better integration of BPF, like with tokens and things like that. A lot of the work here, at least from us, tends to be driven from like the needs of the business and what people would like to use systemd for, in which context. We use systemd a lot for container, for like the plumbing of the container platform that we have. The container platform started as a internally developed and homegrown thing, and over the years it's become this kind of ship of Theseus situation where pieces get swapped out and replaced with, ideally with open source things or with shims on top of open source things, because nobody really wants to maintain their own logic for doing just like namespaces and C groups and stuff like that. So we've been trying to leverage as much as possible systemd here. And whenever it's not possible, we build out the features needed in systemd, working with the community there to make this make sense. There's a talk, there's lots of talks we gave on systemd, but the most recent one is the one in Brno at DevConf that goes over some of the recent work there, and it also talks about the testing framework and using MakeOSI for doing testing there. And finally, we use Chef for config management. Chef, if you've never used Chef is like Ansible or Puppet or whatever. They're all roughly equivalent, I would say. We use Chef in a very bespoke way, which is not the way most shops using Chef use it. This is not a Chef talk, and I will not explain this in detail because I would bore you, most likely, but there is extensive documentation on it online. The long story short, this is designed in such a way that we can have global configurations that then folks can override at a local level. So you can have how you configure sysctls in general. What is the set of default sysctls that should be applied? And that the database people can say, on my databases, I want these different overrides for the sysctls. And then on this one database, I want these sysctls. Apply to everything else. And if you never use Chef writes configurations in Ruby. Ruby is a full programming language, so you can do all kinds of things in it, some more sensible than other. People like to leverage the full power of this, which can lead to interesting situations when your config language is Turing complete.
One good news is that there's the person who led the Chef migration at Facebook at the time. After he left, he still likes it so much that he's working on making it easier for like external people to actually use the same cookbooks that we have.
This is actively maintained. The cookbooks are published. The cookbooks are actually documented quite well. I would say this is one of the better documented projects we put out there. There are several shops that replicate the same setup or use similar setups. I don't know if I would recommend building new infra on Chef these days for a variety of reasons, but I would say if you are on Chef, or if you're building infra on Chef, this is something you may want to look at least for inspiration. Or if you're not using Chef, you might be able to apply some of these to other config management systems. If you use config management, we forgot to put the links here, but there have been a lot of public talks on this in the past that you might find interesting. So this was the quick roundup on the infra. We're going to talk for a little bit now about CentOS specifically, because that's mostly our area of expertise and what we tend to spend most of our day-to-day time. Are we okay with time?
I think so.
Okay.
We have 15 minutes in.
Cool.
So yeah, like why do we pick CentOS? We pick CentOS, one, because it has a stable release cadence, so we can plan ahead of time. Like, hey, we know there will be a code drop every 3 years. It's a branch off from Fedora every, like we know which branch point it will be. So like if we are working upstream, we can plan ahead of time. So the predictability is really nice. I love Debian myself on my personal systems. I'm not sure, like, we don't know when it's going to be released. They maintain strong binary compatibility. Like, it's basically the same guarantee that you have on Red Hat Enterprise, except, like there might be more bugs, like that, you get to catch and report. But technically it should be the same. You get security updates for a long time. So like some teams might not be able to move quickly, and they might be like, oh, like we are migrating 1 year behind everyone else, and you're still getting security updates, which is nice. The tooling is mature and well understood, and CentOS basically move much slower than Fedora, and any tooling change will go into Fedora first anyway, so you don't get surprised when things suddenly change underneath you. The one thing that to flag is that Red Hat and CentOS, so Red Hat Enterprise Linux and CentOS, because all the packages are supported for so long, they only carry like a subset, like about 10% of packages you might expect in Fedora. So there is another project called Apple, which we'll talk about later, that in practice most CentOS deployments have to use to source the missing packages that you actually want to run that is not supported.
One thing I would add that the binary compatibility part is key for production deployments, because in production deployments, you want to be able to update packages on a machine without having to restart services or reboot the machine. And binary compatibility allows you to, in almost any scenario, you can do the NF update from whatever version to whatever version. And because the ABI will not have changed, you will not need to restart anything. Or if you need to restart something, it is well defined. And this is what makes it possible to run this distribution in production without having to effectively take a downtime every time you upgrade something or have to apply a security fix. CentOS is not the only one. Like Debian Stable has the same property for what it's worth, with different caveats. We don't run stock CentOS though, obviously, because things have to be slightly different, at least for our environment. For starters, we don't point production straight to the live mirrors. We have public mirrors that mirror the actual mirrors. These are in the mirror network or mirror.facebook.net. You can use them if you want. And then internally, we snapshot these mirrors every 2 weeks And these snapshots are the ones that the fleet is attached to. And then every 2 weeks, we have some logic in Chef that switches to the new snapshot and runs DNF update everywhere effectively. And this way, when something breaks, we can point to okay, it broke in the 2025-07-25 snapshot. And that makes life a lot easier for everyone. We also have a fair amount of backports for things that we need to move faster than the distribution. And we'll talk later about how we maintain these backports. And we have pipelines for building RPMs for internal like proprietary software that is deployed, that is related to the workload. This pipeline has went through several evolutions, and there's been like lots of debates internally on whether RPMs are the right vehicle for distributing internal software. This has not been settled to this day, and to this day we still use RPM for some things, and then we have some other thing to effectively deploy blobs and binaries internally that people use for other things. Policy-wise, we ship with Btrfs as the default file system, and every box in the fleet uses Btrfs for slash. The vast majority of workloads use Btrfs also for other drives. We have some workloads that use XFS for data drives or other things, or just raw. Like the system that stores cat pictures, like pictures you will post on Facebook or whatever, that runs on like does its own storage management effectively, and it just runs on raw block devices. We don't use SE-Linux. We actually finally excised SE-Linux entirely this year, which I was very happy about. SE-Linux is great if you have people that know and understand and are willing to maintain SE-Linux in production. Also, it's great if you use the distribution policies. In our case, we did not have people willing to maintain these, and we were not using the distribution policy. We were using a custom policy that someone wrote 6 or 7 years ago, and then they promptly left the company. I do not recommend doing that. The policy was also written in like low-level SE-Linux primitives, and it was only used for like a handful of things. It was used for securing Kerberos TGTs, and it was used to like prevent you from messing with block devices on machines used for cold storage, effectively. Neither of which are things that require SE-Linux. There's like other ways you can do that. So we mostly got rid of it, and now we don't have to worry about it anymore. We also don't use NF tables for historical reasons. We still use the legacy IP tables backend of IP tables. This may or may not change in the future. And we don't use network manager. We used to use network scripts back in the day, and then we switched to systemd network D in 9, I think. In 9. Yeah, in 9 we switched to network D, and we've been using network D ever since. We've done a fair bit of work on network D upstream, but I'd say it's worked out better than I would have expected, I would say. I think the functionality-wise, network D covered almost everything we needed. It needed extra coverage on the fringes for like very specific features, but it was mostly there already, and by virtue of being part of systemd, it's very easy for us to work with. Deployment-wise, we don't use Anaconda. We used to use Anaconda back in the day, but we switched to image-based deployments around, I forgot if it was around 7 or 8. Yeah. It's definitely been a while. I think it may have been around 7. Yeah. So we have a system that builds images, and then we deploy this image like just on disk. This thing is ostensibly open source. It's called Antler, but it is basically impossible to use outside of Meta, and like I would not recommend using it. But it does exist if you're curious. It's on GitHub. We have on a subset of the fleet, we have a custom bootloader that uses kexec, and also allows you to do netboot. You netboot into a kernel, you kexec. Netbooting into a kernel is very nice because that means you don't need to debug the TCP/IP stack in grub, which is not the best. Last time I looked, it didn't support fragmentation, which is kind of a problem when you're trying to netboot a machine across the ocean. In general, I would recommend relying on the Linux kernel when you can. That tends to make life a lot easier. We reprovision everything when we do major updates. We just set everything on fire. That is a great way to get rid of craft. And then for my major updates, I mean going from 8 to 9 or 9 to 10. And then for minor stuff, as I mentioned, we just do the NF update, and that mostly just works. I think we have maybe like one outage that requires people to actually spend work on per release or 2, which is not too bad. Generally speaking, it's fine. Yeah, this is not free. Backports, if you have backports, you have to actually maintain the backports. And when people backport things, they fork them and then they forget about. We get people that ask for like stuff all the time, and then they forget about it, and then we discover, why are we backporting the fonts for this dead Phoenician language? Certainly we're not using that in production. and somebody was, and then I file a ticket on Jira asking people to add them back, and the maintainer understandably asks, why do we care about this definition language? These actually happened.
I think the answer was test-driven development.
Yes.
It's one of the test cases. We don't know.
One of the test cases for something that was rendering text was relying on like linear B or something, which is not a live language. Also, the stuff you have to actually maintain it. If bugs get fixed upstream and you don't bring them down, you're kind of screwed. It's not great. I would recommend not maintaining backports internally if you can avoid it. It's just not good. On the policy side, again, whenever you deviate, you pay the price that you are deviating. So things are going to be different then. And then if you find bugs, these bugs may not repro upstream. So you have to do the work on actually getting this to repro upstream and like try to reconstruct the feedback loop.
So yeah, we are getting much stricter internally against in trying to prevent people from just publishing like chucking any package they wanted to the repo and like forgetting about them, because we found out like during some major upgrades, hey, there are these packages, we don't know who owns them, and we couldn't find the source. Like, what is this? And
yeah, my favorite is when we get a package from a vendor that ends up providing OpenSSL or providing some core system library, and then somebody chucks it into the package repo and everything breaks. And this is not allowed anymore, luckily. But we had multiple problems like that have been very fun. The other really fun one was a vendor package that installed something in etc. ld.so.d that overrode the linker path, and then everything was getting some sketchy library preloaded that was injecting symbols and replacing parts of glibc. Again, would not recommend doing that.
We had the opposite too. Like, so we have internal dependencies of a package leaking out, and we also have the opposite, where a package silently depends on a system library. And then we had an outage when the upgrade sent us, and like, hey, that library is not shipped by default anymore.
Yes.
This is Chef.
Yeah. Oh, yeah. That
we have a 5-year-old bug.
Well, Chef is a special case of hell, because Chef, that if you never use Chef, the way Chef is deployed, like from sync or from ops code, is that they give you effectively a tarball that you shove in /opt, and that's kind of its own mini Linux distribution, and which ships like its own libc, its own everything. It's on but it leaks. It's not actually self-contained. So it ends up relying on things from the host, and that does not go well. For what it's worth, we do the exact same thing for our internal software, because our internal software is not linked against the system libc or anything. It's linked against our own platform libraries, and that's wholly self-contained. So in theory, nothing should leak from the OS in there. In practice, that your mileage may vary, but like I can go find the people that made this if it breaks, and we fix it. That's slightly harder with something like Chef. So all of these, like especially the stuff we just talked about, all of these are things that we've kind of discovered over the years, and over the years, as we move forward more from doing things on our own to getting more involved upstream, we found that we could solve a lot of these problems by just doing work upstream and trying to do the work we wanted to happen in the distribution or in the projects or in the community where it makes sense, rather than just deviating on our side. And that's by far been one of the main things that allowed us to keep maintaining this with a fairly small team, because in its heyday, the team that maintained DOS at Meta was maybe a dozen people, and this day, the team that maintains specifically the open source part is the two of us on stage. So, to be fair, there were different scopes involved, but still. Plus, it's not just us. There's also a few more people that do other stuff, but specifically the distribution stuff is mostly us. Working upstream for us means primarily working within the Red Hat operating system ecosystem. This is a marketing picture that has been floating around slides that I've shamelessly stolen. If you don't know how Red Hat Enterprise Linux is built, is open source projects are integrated into Fedora. Fedora is snapshotted every few years into a staging distribution that morphs into CentOS Stream, and then Red Hat takes CentOS Stream and like polishes and sells it as RHEL. But the development for this is all done in the open. This is the graph we generally use to explain this. So you take Fedora Rawhide, which is the development distribution of Fedora, which is updated daily. That is rebuilt daily into Fedora ELN. ELN is a rebuild of Rawhide with the CentOS Stream macros. So if you were making CentOS Stream today, what would it look like? and you get that into ELN. ELN is a fairly new thing. It came out 3 years ago, 2 years ago. Do you remember, Brendan? Yeah.
After 9?
Um,
After 9, right?
Yeah, I think it was something like that. And then when we make CentOS Stream for real, is a snapshot of ELN is taken, and then the connection is severed effectively, and then it becomes its own thing. And then CentOS Stream is developed independently on its own GitLab Forge. And then at some point a release comes out, and at the same time Red Hat does its thing, and at some point RHEL like 10 or whatever comes out. And then CentOS Stream is a stream release, so it has a fixed release, and the development happens always on the same release. RHEL instead has point releases that they deliver to customers, but like we don't run RHEL, we run CentOS Stream, so we primarily care about that. Additionally, there's also a PEL in place, which provides you the entirety of the packages that are available in Fedora as potentially available for CentOS Stream. Not all of them are actually available, but there is the possibility of making them available if somebody does the work. I am not aware of any real-world deployment outside of maybe like government FIP stuff that does not use a PEL. A PEL is pretty essential for having a usable deployment
The FIPS
of this distribution.
some Apple rebuild, right? Like some
I don't know. I
I'm
don't
not
think I
such a-
want to know. All of these, all of the orange boxes in here are boxes one can contribute to, except RHEL. Like you can file bugs for RHEL if you're a customer, but like you don't have the ability to contribute there unless you work for Red Hat. But for all of these, you can do work. Fedora is where you can do like large, I would say, direction setting work. Like Fedora is a great place for doing work that you want to see in the next major release of CentOS Stream. So it's where you can do ecosystem work, you can drive changes, you can drive major.
There is a caveat, right? Like that Red Hat is free to set the direction for CentOS and RHEL direct differently and override changes made in Fedora.
Yes, Fedora is kind of the default, but like CentOS Stream is opinionated on its own, and because CentOS Stream is used to make RHEL and RHEL as a product, Red Hat can definitely make choices there and deviations. So for example, Fedora ships with Btrfs by default. You might be aware that RHEL does not ship with Btrfs by default. And
frame pointers.
because of product decisions, likewise for frame pointers. ELN, as we mentioned, is used in assisting the bring up of the next CentOS Stream major release, and work in ELN can be done mostly around the tooling that's used to build the distribution, but also around package maintenance. Then CentOS Stream itself is the distribution that we ship and deploy in production. You can fix bugs in CentOS Stream itself and send pull requests, but a lot of the, I would say, forward-looking and interesting work in CentOS Stream happens within special interest groups, which we'll talk about in a little bit. And finally, you can branch and maintain packages in PEL if you need additional things in the distribution itself.
There is that thing too, that we are trying to use ELN to incubate the next Apple. It hasn't formally happened yet, but
Yes.
Yes.
I think we have a
We'll
slide
get
on
to
ELN
that,
in a
yeah.
little bit. Yep.
and yeah, like and now let's talk about Fedora. Like we mentioned as the upstream that CentOS derived from. We also have Fedora machines like in Meta, like mostly as desktop machines. There is work in progress on getting CentOS available on desktops, but it's not happened yet. So yeah, like we support this. Well, another team at Meta support Fedora on desktops, in addition to the usual Mac and Windows. I gave a talk a few years ago when I was on that team, so like don't quote me on this because things might have changed. Yeah, like the one interesting thing is that the Mac and Windows fleet at Meta is like mostly engineers using laptops. The Linux fleet is mostly desktops because they have people like who need like beefy machines with like GPUs that obviously you want to run Linux and not Windows because for things like AOSP development. The desktops are managed with Chef, just like production servers, and the nice thing is that like in many cases you can actually share the same cookbooks. So we have cookbooks used in production and on laptops that are basically they might do slightly different things on like a Fedora as opposed to on CentOS, but they can share the know-how and like like if something goes wrong, like the debugging and also the infrastructure for managing like all the Chef cookbooks are basically the same. Let's see what else. Yeah, similar to how CentOS is managed, like basically like we stick to the Fedora workstation defaults, except for things that people override. And of course, there are people running KDE and like Sway and whatever they want.
Turns out engineers running Linux on their desktop are very opinionated.
Yes.
Surprise, surprise. On the tooling front, we also do a lot of work in Fedora itself upstream. Michelle and I are involved in a variety of SIGs, and we maintain far too many packages. We've done work in particular with the Rust SIG, both around collective maintenance, but also because a lot of the tools that engineers and Meta develop are written in Rust, and we wanted to make them available in the distribution itself. So things like Below, for example, or the resource control user space tooling were things that we wanted to make available. We've also done work on Rust RPM, the tool to automate packaging for Rust stuff. Rust, I would say, in Fedora is one of the most pleasant packaging ecosystems to work on, thanks to tooling and automation.
Yeah, like for those who are not aware, like Fedora and Debian both have this thing where like each Rust script is maintained as a package. And so basically building any non-trivial app might have 1,000 dependencies in total.
Yep.
Which is, thankfully with semantic versioning and tooling, it's easy-ish.
It's not the worst.
Yeah.
Michelle talked about the desktop side of the world. We maintain a few GNOME extensions, Argos in particular.
We can finally kill it, thankfully. But,
Did we? Excellent.
We don't need it anymore. But
Excellent.
Like, someone developed a replacement that we are nudging them to open source. So
if you ever have to maintain stuff that touches GNOME shell, it is a fair amount of care and feeding whenever GNOME ships a new release, because the API is not exactly stable. So that's the thing. We've also done work on the Apple Silicon integration. Our kernel engineers were very interested in running Linux on Apple Silicon, because if you're doing, say, file system testing and you run FS tests on a Raspberry Pi 24/7, it eventually catches fire. This is not great. But if you do that on a Mac Studio, that doesn't catch fire, because it's an actual product you can buy that's designed to do that. So there was a lot of interest in being able to leverage that and have these machines available for CI as like nice ARM machines that one can keep in their apartment, shove on their couch, that don't require like having a giant server or something. So we've done a lot of work in ASI. I'm involved in ASI Linux upstream as well, and I was involved on this on a personal capacity as well, because I think this is cool. But with a company hat on, we sponsor and maintain the CI and build pipeline. The build pipeline for this runs on AWS for a variety of reasons. We've given public talks about this if you're interested. But like, it runs on AWS and it spits out build images that then one can install on their Mac and get Linux running on the Mac with Fedora by running a curl pipe bash command you can find on that website. It works. It's completely safe. We also do work in the project itself from time to time, but I would say from the Meta side, the main work has been around CI and infrastructure here. We've also done a lot of change proposals over the years. We're not going to go over all of these. But the main ones, I would say, we're working on shipping Btrfs by default around 33. That has some follow-ups later on. Around 38, we shipped frame pointers by default, which made it easier to do performance monitoring on machines, especially when you have live workloads. One thing we do in production is that we have a daemon running everywhere that runs the equivalent of perf in a loop and then records what that's doing in a data set, so you can query it later. And having frame pointers enabled makes this a lot more useful, because you can actually see what the stack traces are.
And there are some change proposals that are basically just community involvements, where we are helping the community just to build, just to help each other out.
Yeah, a lot of this is also stuff that either the two of us have a personal interest in, or things that people we work with are interested in and ask for our support or to work on, and like it makes sense to do that. Or things like the fact stuff in 42, which was work we were doing anyway for ASI upstream, that it made sense to try to polish a little bit further so it could be generally useful for Fedora as a whole.
For context, that's how you can actually run like a x86 binaries on like a
on ARM. So you can run like Steam on. You definitely run Steam on the Apple Silicon Macs. Theoretically, this might work on other ARM machines running Fedora, but I don't have anything useful enough to test this on. That's not a Mac, except the Pinebook, but the Pinebook is really unpleasant to use. I'm sorry. You should talk about Apple.
Yeah, and now we get to Apple, which, as we just mentioned, like everyone runs. Like, if you are like running CentOS or RHEL. So Apple is kind of like if you are an Ubuntu Debian person, Apple is like Ubuntu Universe, except Ubuntu like nicely rebuilt all the part of Debian they don't want to support and don't support, but like like you have all the packages. The Fedora people decided that no, like we want Apple to start empty each time, and you should only like branch and build the packages you actually want to use. So like so package don't get effectively orphaned. So this is an interesting bootstrapping problem, right? Because now you're like, hey, like CentOS 9 is available. Like there is none of my packages are available that I want to use. That's not in RHEL, and like, or it might be in CentOS 8, and oh, it's dropped in CentOS 9. Like, oh no. We found out the hard way, like every 3 years, that bootstrapping is really tedious because you find out you have all these missing dependencies. So we wrote a tool called eBranch that's kind of like helping basically. So instead of you try to build, oh, there are 10 missing dependencies, you try to build each of those 10 and all of them fail with different missing dependencies. This one will tell you in advance, hey, this is a graph of like missing dependencies, and you can basically start working from the ones that are actually buildable and build yourself up. And there are some additional like tooling for like, hey, file a bug if you don't maintain a package, to actually ask them to nicely like branch the package. It's it automates a lot of the busy work.
Yeah, it automates a lot of the toil and makes it possible to do this work without spending all of your day just running commands in a loop or writing shell for loops. We talked about ELN earlier.
5 years.
Yes.
Oh, 5 years. Thank you.
A lot of the ELN work is around integration. So because ELN gives you a preview of the next CentOS major release, it's a great way to catch issues long before they become an actual problem. And then if you find out an issue and you know it's going to be an issue in a year and a half, that gives you a lot of time to fix it, and it gives you a lot of ways to fix it without causing too much pain. For example, when we were doing early testing for ELN before CentOS 10 branch, we found out there was a bug into the tool we internally were using to sign RPMs that was using, it was basically a broken GPG implementation that was signing packages with a slightly invalid signature. That RPM was validating just fine with the old backend, but with the new backend that was shipping in 10 was invalid. That means we had to rebuild and resign every single package we ever built. That took a while, but we had a year and change, so it was fine. We just told people, hey, please do this in the next year, and most of them did it. So this would have been a lot worse if we had to do this on like, hey, in the next 2 weeks. Otherwise, this is going to block the rollout.
That's how you find out like some packages are not maintained.
Yes, that's also how you find out that things are not maintained, or that like, oh, this comes from a vendor, and the vendor signed it with SHA-1, and the vendor doesn't know how to use GPG, which is very common. Yeah. We also done work on tooling on ELN. Michelle wrote a tool for tracking package provenance effectively, and why is a package branched and where and how, which makes it easy to tell whether we should carry something forward in future version of the distribution. A lot of this work is happening within the ELN SIG. A lot of the internal work in Meta is still mostly internal, and we haven't published as much as we'd like around this, but I'm hoping in the next year, as the CentOS 10 deployment internally becomes a little less exciting, we'd have time to do more work on this and maybe do another talk dedicated around this work. Okay, now let's talk about SIGs, because we are running out of time, and this is
we're eating the Q&A now.
This is one of the things we worked on. As I mentioned earlier, SIGs are special interest groups are one of the best places to do work within CentOS Stream. One of the SIGs we founded and contribute to actively is the Hyperscale SIG. The idea behind Hyperscale is to have a place for companies and engineers that do work in like large scale deployments to kind of do this work together and bring the in-house deployment that people would do anyway out, so that we can just share the work and not just reinvent the wheel. You can find the website there with all of the links. Examples of things we have in Hyperscale are package backports. So all of those backports I mentioned earlier that we used to maintain internally, we now maintain them in Hyperscale, and you can install them as well. So if you would like to have a modern system near your CentOS system, you can do DNF install CentOS release Hyperscale, and that should just work as a drop-in replacement. This is things like systemd. It's also things like Low-level system user space, so things like core utils or util Linux or grep. Generally, this starts very small at the beginning of our release, and then it grows as the distribution gets older. It's also things around developer efficiency. So, like, for example, we have backports of Vim and Emacs because people like having modern editors, and they're like fairly straightforward to backport, so why not? Our virtualization team in-house maintains the virtualization stack. So they maintain backports of Kimu, libvirt, some of the ancillary stuff. Maybe we'll add libgastfs in the future, we'll see. But this was something that internally we used to maintain and was very unpleasant, and it's become a lot more manageable having it out there. We also have packages with configuration alternatives and deviations, like the IP table stuff I mentioned earlier, where we re-enabled the legacy backend. Then we have a dedicated repo as part of the SIG that is not the release one, it's another one that we use for testing features at a large scale. This was used in the past by our friends at Intel to validate some optimization around zlib and deploy them, and then this optimization ended up being contributed to CentOS itself and ended up getting into RHEL and into Fedora. So this was a great example of how to improve the ecosystem overall through this process. Another thing we have here is we have a patch stack on top of the RPM packaging tooling, so around RPM and DNF and librepo, that enables copy on write, and this makes packaging installs way faster if your file system happens to support copy on write, like Btrfs does or XFS. Upstreaming these has been challenging, so it's still a patch set and it's still unfortunately downstream only, but we hope eventually we will find a way to get it upstream. We have a kernel in Hyperscaler. This is not the kernel we run in production at Meta, but it is a kernel that is available that you can test against, that, for example, the systemd folks used to test against. This is an Arc-based kernel. If you were in Neil's talk earlier, he talked about Arc. Arc is the kernel tree that all of the Red Hat ecosystem kernels are derived from.
Always ready kernel.
Yes, always. Yeah. This kernel in particular is basically the Fedora kernel with the RHEL CentOS stream configuration applied to it, but with extra things enabled. So it has Btrfs support, it has Waydroid support, it has all of the Apple Silicon enablement on it. So it kind of tried to provide a superset of things and give something a bit more useful if you need to run modern tooling on a CentOS system. This comes with its own user space, so we ship Btrfs procs, for example. We ship a backport of eTool to enable support for modern NICs because companies love to add magic things that need support in eTool. We ship a K-patch that actually works because K-patch that's shipped in CentOS stream doesn't have the building your own kernel patches part. It only has the consuming kernel patches that someone else built for you part, which makes it not very useful for us because we build our own kernel patches. K-patch works really well, by the way. If you have a need to do that, this is a very good way to do kernel live patching. And we have live images and containers and a bunch of other things that you can use to play with this. We have given a lot of public talks about Hyperscaler, so I won't go over in detail on it here. I will give you a quick example of what we do with systemd. So with systemd, we have a branch tracking the very latest systemd. This is basically the Fedora OI spec, and in fact, whenever we need to make changes here, we actually try to contribute them to Fedora with whatever gating is necessary, so we don't have to keep maintaining them. We have a repo on the CentOS GitLab, and then we have another repo that's made by CI, which is the systemd sources exploded with all of the patches applied on them. So if a software engineer wants to repro a bug or do development on systemd, they don't need to learn how to use mock, which we found was a very high barrier for software engineers. We ship builds for Stream 9 and Stream 10. This is the full systemd, so it has all of the daemons enabled, no matter how stable or well integrated are. We don't use all of these in production, but we use, for example, UMD, we use NetworkD. But we also ship things like ResolveD, which you don't run in production, but it is available if you want to run it. I happen to run that at home, and it works fine. This has SE-Linux enablement, although the SE-Linux enablement, your mileage may vary on how well that'll work. We don't use that at Meta. It's not super well tested. I would say for all of the core demos, it should be fine. But if you want to run something like HomeD, you might find some trouble there.
It's probably okay if you use something that's enabled in Fedora, because
yes.
I think we just borrowed Fedora's policy mostly.
If you use things that are shipped in Fedora, that should work fairly well. And we have a GitLab pipeline set up, so whenever somebody makes a NMR there, it automatically runs tests. We run a build. The systemd build that is done runs the full test suite. The test suite spins up a bunch of containers and VMs to exercise various things. So we can have a reasonable confidence this will not blow up in our face.
And now we can talk about another SIG. This is the proposed updates, which is a spin-off from Hyperscale. In the past, we only had one SIG, and sometimes you have issues that, like it's not like that the package needs to be backported, but you have an urgent fix that need to be applied. And you're like, well, we have a SIG that we can use to build packages, why don't we use that? Except it's kind of not really the purpose of Hyperscale. So this is now split. The idea is that CentOS Stream basically will eventually become the next RHEL minor version. But, because there are phases in the development where they're like, well, we are stabilizing the next RHEL. We are not really reviewing many MRs to CentOS Stream itself. Whereas if you are running CentOS Stream in production, you're like, but I need my bug fixed yesterday. Like there might be a CVE, there might be there's this bug that's I cannot use my new hardware or something. So we have this middle ground where we say hey, as we still want to encourage people to contribute upstream and not fork. So as long as you submit an MR to CentOS Stream and you file an issue asking Red Hat to please fix the package, we can temporarily build things in this SIG, and anyone can consume it without building it themselves, which is also a nice way to validate whether the fix works or not. You can say hey, this is my MR, and we tested it on 1,000 machines and it's fine. As you can see, this is a snapshot taken a few months ago of the kind of issues we have. So it's a wide mix of things. There are bug fixes, security fixes, enhancement requests where hey, I think there's one that enable fractional scaling matter.
Yeah, this is a good way to have something that allows you to move a bit faster, so you're not beholden to the maintainers on the CentOS Stream side, because it will take them a while to merge things, and then it will take them a while to build things because they have to qualify them for RHEL. And at the same time, it allows you to provide signal to upstream because you are actually building this and testing it in production. So when the maintainer goes around and reviews your MR, they can have a build, they can see it's already being used. So we hope it will make it easier for people to contribute changes to Stream as well. This is mostly all we had. The general gist of it that we wanted folks to take away with was that it is a lot easier to do this kind of work upstream. If you do this work in-house, you will eventually build more and more tech debt, and you will have to scale your organization larger and larger to be able to deal with the tech debt. And if you can tackle this head on and expand the initial work to do this upstream and build the infrastructure so that you can do this work upstream, things become a lot more tractable. And as a byproduct, your engineers are happier because most people are happy to do work upstream, in my experience. And the community overall improves. And in general, this makes the world better for everyone. This is all we had. We're happy to take questions if there is time. There are no clocks in this room, so it's hard to tell. But okay.
I was kind of curious how you deal with maintaining forks. So if you have an upstream project and you have to maintain a patch on it for a long time and you need to be backporting new versions of it, do you do that as part of your team or part of a different team?
So it depends. For open source projects that are shipped as part of the distribution where this needs to be done in part of the distribution, we do this in Hyperscale. For everything that is not encumbered, which we effectively have we have one example of something that is encumbered, but that's not a backport. That's another thing. But for everything that's not encumbered, we can do this in Hyperscale because it makes it public. We have a way in Hyperscale also to gate a patch as something that is specific to Facebook. So we can gate patches in a way that these don't get shipped to the real world. They're still out there. You can still look at them, but you don't get them unless you pull from a specific repo. You still have to do the work where you still have to do the three-way merges and all of that. But at least it's out there. It's in a place where it's very visible. It's easy to build automation around it. It still kind of sucks, but it makes it more tractable, I would say. We do end up doing a fair bit of this work. It depends on the teams that ask it, and it depends on what the package is. Generally, if it's something small and the team that is asking it will not have the capacity to support it, we end up doing it ourselves. If the team that's asking it is asking for something insane and has the ability to support it themselves, we'll coach them and either onboard them on the SIG, the virtualization case is a good example where the very folks that we work with were willing to do the work. It's an actual team, so it's not like one person, but it's a team that is committed to doing this and sees the value. But if it's like, I don't know, some product needs a weird font, there's no point in like harassing somebody in doing all of these themselves. We'll just do it and then like track it so we know where it came from and then follow up to make sure that when we can get rid of it, we can get rid of it.
One specific example, I think, for something that actually is heavily patched is K-patch.
Yeah.
Because our K-patch has PGO support, and practically there's like around like 15 to 20 patches that are still not merged into the upstream tree. And what we find that if you're using RPM is that auto patch is your friend, because you can just say, hey, you know, like any patch within this range is our patches, and you just replace that block of patches like with whatever like a git like a format patch like spit out, and you don't have to touch it anywhere else.
Yeah, K-patch is also a good example because the folks that do the PGO work are actually involved with K-patch upstream.
Yep.
So we can tell them like, hey, we can definitely build this for you, but like, can you go tell upstream to make a release first, so we don't have to carry 150 patches and it's only 15, or can you rebase your tree? So generally, you're dealing with people that are technically competent, so it's not too bad. I would say for us, the general expectation is that you're dealing with like the customers we have internally are other engineers. So you're dealing with people that they may not have the time to do something, or it may not be in their like specific skill set, but you can work with them and you can figure it out together. Any other questions? Brandon, what's up?
I was curious. So you found good ways of working with Fedora and ELN and CentOS and whatnot. So things are working for you to a degree, but I wonder what would be even better than what you have right now?
We should probably repeat the question.
The question is what would be better? What could be made better? I think having a better way to access, and I told you this before, but like for the recording, I think having a better way to access maintainers on the CentOS stream side would be useful. I think right now we end up relying on a lot of back channels that we have because we've been working in this space a lot. We know a lot of people, so I know I can hit people like on Matrix and like ask them, hey, can you do me a favor? And I know there's a private comment on this ticket. Can you do me a favor and tell me if there's something I should worry about? Or can you go ping this person on the internal chat because I know they're not looking at their emails? And like, it would be nice to have a way to do this without requiring back channels. And I think that would make for a more accessible and welcoming community. The other thing that I think we haven't quite figured out how to deal with as an ecosystem is the vendor stuff. Like the vendor stuff still badly sucks. It sucks for us, it sucks for the vendors, it sucks for the distro. I don't think we have a good story there. And I think we can probably do something, but it's hard.
For the recording or the rest of the audience who's way out in the world, can you talk about what the vendor stuff is?
The vendor stuff is you're working with a third-party vendor that ships you software or ships you hardware, and it requires some kind of integration with the distribution. Normally, the vendor will only qualify things for a small subset of targets. And like we found that in many cases, you will get vendors that are like, I only ship this for Ubuntu. Like, well, we don't run Ubuntu. And this conversation generally goes two ways. If you're talking to somebody you have leverage with, or that you can build a relationship with, you can generally work something out, which ends up being like, hey, can you qualify this on CentOS stream and like ship us RPMs? Or hey, let's work together. Or oh, hey, this thing should probably be open source. Why don't you like throw it on GitHub and then we'll package it? That's the ideal outcome. That understandably doesn't happen all the time. But the other thing that can happen that happens quite a bit is people will like either not have the engineering capacity to do this because it's a small shop, or it will be very difficult to get buy-in from management at the company and get people to understand the value of doing this kind of work. So you end up in situations where you have to explain that like, well, I know you're qualifying for RHEL, and I know you have your stuff tested on RHEL 9. You do know that RHEL 10 is coming out in a while, and we know the date. You also know you could qualify your stuff for stream now, and then when RHEL comes out, you could give it to your customers day of, and not have to wait 3 months, and maybe your customers will be happier. So you end up having a lot of these conversations. But it is a hard problem because the generally, like when you talk to the engineers understand the trade-offs involved, but it's difficult to make the business case and get this propagated up in the company. So,
I think it's fine agreeing with that. Like you can have a vendor who supports RHEL 9.2, but you want to move to 9.3.
yes.
So it can be even more fine-grained. If you're running software that requires RHEL 9.2 and you want to move to 9.3, your vendor might not let you do that.
Yep. And that might be it really depends. Like it's also the situation where like the stuff I'm talking about is stuff in the server space. There's also a lot of these in the desktop space. So if you run, I don't know, some proprietary software for doing CAD for electrical engineering that costs $200K, that's only supported on very specific RHEL point releases. Just buy fucking RHEL. Like obviously, if you're spending that much on the software, just buy the damn point release that you're supposed to run and run that and be done with it. Like I think that's a moot point. That's not a problem. The problem is when you have things in the server side that need to integrate in existing infrastructure where you don't have the luxury of picking whatever OS the vendor wants, because otherwise it's madness to support. I think we might be at time.
Yeah, I don't think there's a talk after us. But
Yeah, I haven't checked, but yeah. Cool. Thanks, everyone.